Welcome back to Implicit. I'm Daniel, and in this video we will learn how to enrich existing types with implicits, a technique that's lovingly known as pimping a library. So in the part 4 implicits package, I want you to go ahead and create a new Scala application. Let's call this Pimp My Library. Of course, make this an object, and as usual, extends app. So enrichments allow us to decorate existing classes that we may not have access to with additional methods and properties. So wouldn't it be nice if we could say, for example, 2.isPrime? Wouldn't that be cool? Well, there is a way to do that, and that's called implicit classes. So if I define an implicit class, and I'm going to call this rich int, implicit classes must take one and only argument. Let's say it takes a value of type int, and let's say this has some additional method. For example, let's call this isEven, and this returns a boolean, and of course the number is even if the value mod 2 is equal to 0. And let's add another method, let's say square root, which is a double, and this will call math.squareRoot. So given the implementation of this class, we can of course say new rich int of 42.squareRoot. So this is all well and good. We are just calling the square root method on a rich int instance. But given this is an implicit class which wraps an int, we can also say 42. For example, isEven. This is freaking cool because with just a couple of lines of code, we added the isEven functionality to a probably inaccessible int class. So this is called type enrichment, or lovingly pimping. This is how, my friends, we could write things like 1 to 10. If you take a look at this underscore right over here, it's suggestive of an implicit conversion. So the to method here is a method from rich int, which is in the package Scala. At the same time, this is how we could say import Scala concurrent duration. You see where I'm going? 3.seconds. Again, this underline here is indicative of an implicit method. So .seconds here is a method from duration conversions. Now, the implicit conversion between int and these guys, duration conversion and Scala.richInt, is done with implicit methods buried within the code. But the principle is exactly the same. So going back to our little source, when I type 42.isEven, the compiler interprets that as an error in the first place, but it doesn't give up. It searches for all the implicit classes or all the implicit conversions that can wrap a type int into something that contains the method isEven. The compiler then inserts an invisible constructor call in this case. So basically rewrites 42isEven as new rich int with 42.isEven. And that's how the code compiles. A pattern often seen in practice is to make these implicit wrappers extend an eval for memory optimization purposes. Now, extending an eval imposes that I make this a val. Now, one restriction that I want you to bear in mind is that the compiler does not do multiple implicit searches. In the sense that if, for example, I have an implicit class richer int, which wraps rich int, and it has some kind of, say for example, def is odd, which implements that as richInt dot value mod 2 is not equal to 0, then I cannot say 42.isOdd. So this will not compile. That's because the compiler attempts to expand or wrap 42 into whatever conversions it can access, but it doesn't do another search to enrich those as well. So it can, for example, wrap 42 into a rich int, but it doesn't wrap the rich int into the richer int in another step. So let's comment this out and let's do some exercises, which are probably going to be very fun. I want you to enrich the string class. I want you to add an asInt method, which will parse the string and return an int. And I want you to add an encrypt method, which does a Caesar cipher. So for example, if I have John, encrypting John with a Caesar cipher of, say, 2 characters, we have JKL, OMN, HIJ, and NOP. So this is the encrypted value of the string John. So I want you to do that. Then I want you to keep enriching the int class with 2 methods. A times, which will take a function as a parameter, so that you can say 3.times do something, and a method called multiply, which will take a list as an argument. So if, for example, I say 3 times list 1, 2, then this will concatenate list 1, 2 3 times. So I'm gonna return list 1, 2, 1, 2, 1, 2. All right, so pause the video and have fun with these methods. All right, so I hope you did those. These are one of the simple yet fun exercises. And let's go through those in turn. So of course we can have an implicit class. Let's call this a rich string, which wraps a string. And we have a couple of methods here, asInt, which returns an int. And we can parse the string by calling a small Java function saying integer value of string. Notice that this call here is also underlined. That's because integer value of string returns an Java lang integer, which then Scala converts to an int. All right. And the encrypt method, so def encrypt, let's take a small int parameter for the Caesar cipher. So cipher, let's say distance, which is of type int, and it returns a string. And here is where the implementation can get interesting, but I'm going to have an unfair advantage by calling string.map, because string can be auto-wrapped to a sequence of characters, and for every character, I can say C plus cipher distance. Now the trouble is that adding a character with an int gives me an int, so I'm going to convert that to a character. So I'm just going to say as instance of character. And that should be it. So if I print line, for example, the number 3 dot asInt plus the number 4, I should see the number 7. And if I print the name John, encrypt with the distance 2, then I should be seeing this little obfuscated stream here. So the number 7 and LQ, of course, OPQ, because I don't know the freaking alphabet anymore. As for the int class, we can continue enriching this in rich int. So we have a method called times, which takes a function, which is a 0 lambda to, say, unit. And this just returns unit. And the implementation is going to be based on an auxiliary function. So if I define a method times auxiliary, which takes a number which is an int and returns unit, then I'm going to say, well, if n is less than or equal to 0, then I'm just going to return the unit. Otherwise, I'm just going to run the function and do times auxiliary with n minus 1. And I can say times auxiliary with the value inside. As for the multiply method, I can say def star, and I can receive a list here, which is a list of whatever. I can also type this. All right, and this will return a list of the same type. And again, with an auxiliary method inside, let's concatenate n times, and this returns a list of t. And if n is less than or equal to 0, then it just returns the empty list. Otherwise, I can concatenate with n minus 1 plus the small list that I receive here as a parameter. But of course, we have the plus plus concatenator for lists. All right, and at the end, I'm just going to call concatenate with the value that I store in this rich int. If you want to implement this concatenate auxiliary method in a tail recursive fashion, you're more than welcome to. This only serves as an example. So let's test them out. So if I print line, actually not print line, I can say 3 dot times the lambda that just prints Scala rocks. And if I run this code, we have the function run 3 times. And I can also print line 4 times list 1, 2, because the start method now belongs to an implicit wrapper over int. So if I run this again, I should see the list 1, 2 repeated 4 times. So 1, 2, 1, 2, 1, 2, 1, 2. So this is very cool, but we're not even done. There's more where that came from. So let me ask you a question. Wouldn't it be nice if we could auto-convert strings to integers and just say, like they do in JavaScript, the string 3 divided by 4? Well, if we want it to be hated by every programmer in existence, we can, with implicit conversions by implicit methods. So we can say implicit def string to int and this takes a string as a parameter and returns an int, and we'll just say integer parseInt or value of string. So we can now say print line, for example, the string 6 divided by 2. So if I run this, the code will compile and will print the number 3. The same mechanism happens as with implicit classes. The compiler is attempting to call the slash or the division method on a string, and of course it's not possible. Then the compiler looks for all implicit classes and wrappers and conversions that, given a string, they return something that has the slash method. Apparently, it's found our little string to int implicit def, so it turns this string into an int by basically rewriting this as string to int from the string 6, then divided by 2. Now, this is a more general conversion technique than implicit classes. Implicit classes are basically plain classes with an implicit conversion. So we can say class rich, let's say alternative int with a value, and an implicit def. Let's say enrich, which turns a value of type int into a rich alt int by creating a new rich alt int with the value. So this is basically an equivalent implementation of an implicit class. So the actual equivalent code is implicit class rich alt int with a value. Now, although the implicit conversions with methods are in general more powerful, they are discouraged. And let me give you an example. So let's call this danger zone. Let's say we have an implicit conversion method, so an implicit def, that turns an int to a boolean. Remember the C style? Let's just say that this into boolean returns true if the number inside is equal to 1. So for C programmers out there, the goal here is for us to say if I, or if a number, if n, then do something, else do something else. And we can pass a number here as if it were a boolean. And the way that we can do that in Scala is to just write an implicit conversion method. So let's do the following. Let's create a condition value which says if a number, let's say if 3, then okay, else something wrong. And then we print line a condition value. What do you think this will print? Well, it prints something wrong, because our implicit conversion method returns true only if the number is equal to 1. The problem here, and the whole danger zone in implicit conversions with methods, is that if there is a bug in an implicit conversion with a method, it's super hard to trace it back. Implicit methods tend to be part of library packages, which are generally in a very different part of the code base and likely written by different people. So if you are part of a huge project and something is wrong in an implicit def, it's very hard to trace it back, which could cost you days or even more of development time. So, as a general set of best practices, maintain type enrichment to implicit classes and type classes, as we'll see in the next video, as much as possible, and avoid implicit defs. Also, if you have multiple implicit values, package them clearly and bring into scope only what you need and when you need it. But if you do need type conversions, make them as specific as possible and never with general types. Alright, so I hope you've had a lot of fun in this video. Join me in the next video where we will put what we've learned to good use and make the type class pattern a truly complete tool for rockstars.